Thank you so much. It's a tremendous honor to be on this stage, not only, as Deirdre said, in this place that is so important in the history of the world and this wonderful building, but also to follow one of my great intellectual heroes, Deirdre McCloskey. Now, when I was a student, the future of the world was bleak. The population explosion was unstoppable, global famine was inevitable, the oil was running out, the desert was advancing, the ice age was returning, a cancer epidemic caused by chemicals was going to shorten my life, the urban decay was getting worse, so was air pollution, water pollution, species extinction, acid rain. My sperm counts were going to fall, and a nuclear winter would finish me off if the Y2K computer bug didn't bring civilization to its knees. As I got older, I realized that these things either didn't happen or happened much more slowly and much less badly than expected. Instead, the income of the average citizen of the planet doubled. Life expectancy increased by a quarter. Poverty and child mortality were halved. We became not only wealthier, but healthier, happier, cleaner, cleverer, kinder, freer, more peaceful, more equal. I've got graphs if you want to show all that, but arguably, the average citizen of the world has experienced all that. And I'm just coming at this with a very, very fundamental question. What is prosperity? What is it that enables you to be better off than your grandparents? And also another question, why human beings? Why did that happen to us and not killer whales or octopuses or something like that? And my answer to the second question is that it's because we collectivized our intelligence. We invented a collective brain. We started to share ideas. We started to let ideas have sex. And that what prosperity really is the reduction in the amount of time it takes to fulfill a need, and therefore the chance to fulfill more needs. Because self-sufficiency is just another word for poverty in the end. If you had to fulfill all your needs for yourself, you had to get up in the morning and provide for yourself. How long would it take you, for example, to provide yourself with artificial light? You'd have to go out into the countryside, find a sheep and kill it, get the fat out, render it down, boil it down, turn it into a candle. You know, it would take quite a long time. How long does it actually take you to acquire an hour of reading light? That's about 1200 lumen hours. That's an 18-watt compact fluorescent bulb burning for about an hour. Well, the answer is, according to Bill Nordhaus, that it took, in 1997, about half a second. Half a second on the average US wage to acquire an hour of reading light. Back in 1950, it would have taken about 8 seconds. So that's 7.5 seconds that you've got that your grandparents didn't have that you can spend fulfilling another need. Or if you're like my kids, you just leave the lights on. And back in 1800, 15 minutes to get that much light. 15 minutes of work, that's quite a lot for an hour's light with a kerosene lamp. In 1880, in 1800, 6 hours. It would have taken 6 hours to earn the light from a tallow candle on the average wage. Most people could not afford candles in 1800. That's just another illustration of Deirdre's and Joel's wonderful points about how much we have actually improved. Well, on my desk at home sit two objects. This is one of them. It's an Ashwalian hand axe from 500,000 years ago, of the kind used by Homo erectus, with very little change for about 1 million years. And beside it sits an object of exactly the same size and shape, which I use every day. Actually, I don't anymore because I now use a Mac, but anyway. Until a couple of years ago, I used this thing. They're obviously, the similarity isn't that interesting. It just means they were both designed to fit the human hand. We all walk around with hand axes all the time when you think about it. But what about the differences? The object on the left was made from a single substance and to fulfill a single purpose. The object on the right is made from lots of different substances, and it combines not only lots of different things, but lots of different ideas. The idea of computing, the idea of plastic, the idea of lasers, all sorts of ideas have gone into this. Ideas that occurred to different people in different times and at different places that have actually come together. It's cumulative in a curious way. All technologies are like this. They all combine ideas. This is my favorite example. It's called the pill camera. You eat it and it takes a picture of your insides on the way through. It came about after a conversation between a gastroenterologist and a guided missile designer. Now, if you're trying to explain why human beings have these cumulative technologies, the word culture simply doesn't do it, partly because other animals have it. Chimpanzees have it. They teach each other how to crack nuts with rocks. What's different about our culture compared with other animal cultures? And the answer, I think, comes back to exchange. The fact that we started exchanging one thing for another, and other animals never did that. We're the only creature that does that between strangers. You get it between related individuals, and you get reciprocity. I'll scratch your back, you scratch mine. But that's not exchanging different things at the same time. It's exchanging the same thing at different times. As Adam Smith famously said, no man ever saw a dog make fair and deliberate exchange of a bone with another dog. Because my body's an accumulation of ideas too. The idea of skin cells, the idea of nerve cells, the idea of liver cells. Evolution is cumulative. What makes evolution cumulative? The answer is sex. If you don't have sex, evolution doesn't accumulate ideas, doesn't bring them together. Let me show you what I mean. In an asexual population, you can get two different mutations, a green one and a red one, and they end up in different lineages and therefore in competition with each other. And in this case, the green one's superior, the red one has to go extinct. But in a sexual population, at some point, an individual can inherit both from different parents. And therefore, you can draw upon the genetic inventiveness of your whole species if your species is sexual, not if it isn't. And I think exchange had the same impact, therefore, on cultural evolution that sex had on biological evolution. And why is exchange so special? Well, in the end, it kind of all boils down to this wonderfully simple idea which has been described as the only proposition in the whole of the social sciences that is both true and surprising. And it occurred to a London stockbroker called David Ricardo in 1817, and it's called the law of comparative advantage. And he was trying to explain why Britain was better at even if Britain was better at making everything than Portugal, it would still pay to trade with Portugal. Those were the days. But I'm going to retell it in Stone Age terms. Here's two guys sitting around a fire, Adam and Oz, and they both need a spear and an axe. Adam takes 4 hours to make a spear and 3 hours to make an axe, whereas Oz takes 1 hour to make a spear and 2 hours to make an axe. So Oz is better than Adam at both spears and axes. He doesn't need Adam. Adam is a waste of space. Or is he? Because if Oz were to make 2 spears, and Adam were to make 2 axes, and they were to trade, then they would each have saved an hour of work. Oz would have worked for 2 hours instead of 3, and Adam would have worked for 6 hours instead of 7. Now, this is only true because Oz is better at making spears and Adam's better at making axes. But then if they start doing this, that's going to be true. The more they specialize, the more exchange is valuable. And the more they exchange, the more specialization is valuable. It's a kind of fast breeder reactor, this. Once you start doing it, it's just going to put you on a road towards innovation, which is, of course, where all the improvements in living standards are going to come from. And if you go back to this image of the axe and the mouse and ask yourself, who made the objects? The object on the left was made by a Homo erectus for his own use. The object on the right was made for me by a team of people. They had a project called Make Matt Ridley a Computer Mouse. And there were lots of them. Hundreds of them, thousands, millions of them when you think about it, because you've got to include the man who was growing coffee in Brazil that was going to be drunk by the man on the oil rig who was drilling for oil, whose oil was going to be used in the plastic factory. Do you see what I mean? You know, once you start trying to work out who contributed to the making of this one simple object, you get to the most gigantic number. And they were working for me. Now, in the old days, if you had people working for you, it meant they literally worked for you. It's a fair bet that Louis XIV did not make this silly outfit for himself. Louis XIV had 498 people to prepare his dinner every night. But a bunch of tourists going around Versailles today Each of them has 498 people preparing their dinner tonight. They're working in bistros and cafes and restaurants all over Paris and shops, but at an hour's notice, they're prepared to produce for these people a meal that's probably just as good as anything Louis XIV had. It's more likely to have mangoes in it, and it's less likely to have salmonella in it. We're not the only creature that works for each other. You do get other animals that work for each other. That's what the social insects are all about, that the workers work for the queen and the queen works for the workers and the soldiers work for both and so on. You know, that's the whole point of social creatures like this. But there's a big difference, a key difference. An insect colony is just a family. It's a very big family. They're all related to the queen, because they have a reproductive division of labor. That is to say, they delegate reproduction to the queen. That's the one thing we don't delegate. It's the one thing we like to remain self-sufficient in. We like to do our own reproduction, when you think about it. Even in England, we don't expect the queen to do our reproducing for us. Now, what I want to know is, how far back do you have to go to find this habit? How far back do you have to go before you find human beings didn't exchange with strangers, didn't swap different things with strangers? How old is trade, in other words? And the answer, nobody quite knows, but it looks like it's at least 100,000 years, something like 120,000 years, sort of 10 times as old as agriculture. This is when you first start to find evidence in Ethiopia that jasper and flint and obsidian and things like this is starting to move long distances. And here's another example. This is from Algeria from about 100,000 years ago. These are shells made into beads. They're being worn as beads. They're 100 miles inland, but the species from which they're made lives in the Mediterranean. Now, objects moving 100 miles means trade. It doesn't mean migration. How do you know that? Because you go and look at relatively modern Australian Aborigines and you find that their stone tools moved over very long distances, but entirely through trade, not through migration. And you just don't see this before this time. And this is starting to suggest that suddenly people are beginning to swap things with strangers between bands. Neanderthals never did this. Neanderthal sites only ever have local materials in them. You can never find distant objects in Neanderthal sites. And perhaps this explains why we, because we're Africans, why we drove the Neanderthals out of Europe. Because, for example, in the Caucasus, there's a site with a Neanderthal site from about the same age as a modern human site on opposite sides of the valley. The moderns have chert and jasper and things that have come from really quite a long way away in their site, because they're trading with their neighbors. And that means you're drawing upon the inventiveness of other people. A good idea that happens hundreds of miles away can be used for you in your competition with the Neanderthals. The Neanderthals can't do that. Neanderthals were very clever creatures. Their brains were bigger than ours by the end. Bigger than ours are now, anyway, because ours have shrunk a little in the last 50,000 years. So there's nothing stupid about the Neanderthals, but they're relying on individual brains. They're relying on their own brain power. They're not relying on collective intelligence. They're not sharing knowledge in this way. What happens when you cut people off from their exchange networks? The answer is that their innovation rate drops precipitously. Tasmania became an island about 10,000 years ago. Until that point, it was a peninsula on the south of Australia, and the people living on it shared the technologies that other Australian Aborigines had. But because of rising sea levels, it became an island, and after that, there was no contact for 10,000 years between Tasmania and the mainland. And what happened was not just that the Tasmanians didn't share in the innovations that happened after that time, the boomerang, for example, but they actually lost technologies that they'd had before that time. They gave up the ability to make bone tools altogether, for example. Now, it's not quite clear why, but the suggestion that the anthropologist Joe Henrich has made is that their collective brain was simply too small to sustain the specialized skills that you need to keep technologies alive. That effectively, the sort of 4,000 or so people on the island, only a few of whom would have been young adults, who are the people who kind of, do most of the work and the learning in these societies, was simply too small a number to keep some of these skills alive. And skills are going to die off by accident when the key guy who knows the skill falls over a cliff or something like that, and they're not going to get replaced in the same way. So the Tasmanians only had a small collective brain after that point. There's nothing wrong with their individual brains, but it's the collective brain that counts. Tierra del Fuego is a control for this experiment, because Tierra del Fuego is just as isolated an island, it has a similarly small population on it, just as remote an island, I should say, just as inhospitable is probably the right word, because it's not as remote. The Magellan Strait is much narrower than the Bass Strait, and so there was trading contact throughout that 10,000 years across from Tierra del Fuego. So the Fuegians were drawing upon a collective brain the size of South America, and they never saw this technological regress that the Tasmanians did. What I'm essentially arguing is that we've been using the cloud, we've been wikinomic, we've been crowdsourcing for 100,000 years. It's just that we've got very, very much quicker and better at doing it. Pacific fishing technology, of which this is an example, this is Maori fishing tackle from before Western contact. Pacific fishing technology shows a fascinating pattern, which is that the more contact there is in trading terms between islands, the more sophisticated the technology. There's also a correlation with island size, population size, but the key thing that intrigues me is that if you're in contact with other islands, you can have a more sophisticated technology than if you're more isolated. They're using the cloud to invent their technologies. And so the first social networks are essentially the trading networks. When the Phoenicians or the Venetians or whoever networked the Mediterranean, they got ideas from different parts of it and brought them together and gave specialized tasks to different parts of it, and they created effectively a social network which was also a collective brain. Fibonacci, the guy who brought Indian numerals to Europe, he was brought up in the Maghreb. He was the son of a Genoese trader who traded with Arabs. He pinched the idea from others. And that's what you need. That's why trade is so important. It enables you to draw upon the inventiveness of people in different parts and different areas. And for me, what's really intriguing about this idea of the collective brain, to go back to this image, is to ask yourself, who knows how to make the technologies we use in the world? Homo erectus knew how to make an axe. You can actually find places where they sat down and chipped the rocks apart to make their own axes. But who knows how to make that mouse? How many people know how to make a computer mouse? The answer, of course, is nobody. There is no human being on the planet who knows how to make a computer mouse. I'm just quoting from a famous essay by Leonard Read, the economist in the 1950s, called I, Pencil, in which a pencil sets out to discover how it was created and comes to the conclusion that although millions of people contributed to the creation of this pencil, not one of them knew how to make a pencil. The president of the pencil company doesn't know how to make pencils, he just knows how to run a company. The person on the assembly line doesn't know because he doesn't know how to mine graphite in Sri Lanka. And the man mining graphite in Sri Lanka doesn't know because he doesn't know how to chop down trees in Oregon. The knowledge is so collectivized that for almost everything we think of, every garment you're wearing today, nobody knows how to make them. The knowledge is distributed among people. So it's not a matter of us getting better at things through our brain power or anything like that. It's not a matter of clever people telling us what to do. It's a matter of sharing the knowledge as widely as possible. As we've gone from living in villages to living in cities to living in a great big internet, so we have gone from a small collective intelligence to a bunch of big ones that are quite well connected, to one gigantic one where we are effectively operating as a great big brain. That's a picture of the internet, but it looks like a picture of a neural network. It looks like a picture of a brain. Here's a picture of a real brain. They're kind of similar, and that's because they are the same. We're the nodes in the network of the neural network that is the collective brain. And so what I'm arguing is that as we've gone from making objects like this with individual intelligence to making and crowdsourcing objects like this with collective intelligence, so that is what has enabled us to raise our living standards. And the more we do that, the more we exchange and specialize, the faster we can raise our living standards, and the more we interfere with that process, the slower or the more we'll put them into reverse. Thank you.